Hello there, I'm Will Robinson Smith for Spaceflight Now. Thank you so much for spending part of your day with us. And coming up on September 24th, the culmination of a mission called OSIRIS-REx, a spacecraft that launched back in 2016, went to the asteroid Bennu and is getting ready to bring a sample of that asteroid back to Earth, landing the morning of September 24th. And we had the opportunity to speak with a couple of folks who were integral to that mission. For Lockheed Martin, we spoke with Sandy Friend, who is the program manager, as well as Bo Bierhaus, who is the TAGSAM lead scientist, as well as a co-investigator for the mission. Sandy and Bo, thank you so much for taking part of your day to join us. I know it's a busy week ahead of sample return, so thanks so much for spending some time with us.
Of course.
Yeah, thank you for your interest.
Absolutely. And, Sandy, I want to start with you since your background has led you to a lot of interesting and intricate missions, a lot of them Mars bound. And so wanted to start with, how your involvement with a number of Mars missions helped inform your current role here with OSIRIS-REx.
I've been involved in a lot of deep space missions over my career. So on the development side and on the flight side, and every mission you learn from, and you're able to take those lessons learned forward. I would say more than Mars, the Genesis and Stardust sample return missions were more applicable for those lessons learned to take forward to OSIRIS-REx.
Yeah, and that was going to be another question I wanted to ask you about. In those two prior NASA-related sample return missions, what were some of the lessons learned from those that you were able to then bring over to OSIRIS-REx?
Yeah, so I joined those missions in flight already in operations. And so there were things that I wish we had had from development that were not easily accessible. So maybe some data, right? Different test information. So going forward to OREX development, I was able to take that lesson learned and say, here are things that we must make sure we carry forward to the flight team, knowing that we were going to have some subject matter experts retire or move on to their next programs and maybe not be accessible to us. So taking forward that information, as well as some additional ground testing that maybe wasn't performed on those previous missions, to say, hey, this ground test and this test data will be very useful to us in 7+ years when we're getting ready to return the sample return capsule.
And before we get further into both your backgrounds, I want to take a step back and just acknowledge what I did up top, which was, this is the week leading into, sample return, sort of the big, day of that all this has been culminating to. Both of you, question to the two of you, how are you feeling going into this last, final week before, kind of the moment of truth here?
I'm excited. We've been planning this for years, a decade. So I'm excited to be into the execution phase and to finally get these Bennu samples back on the ground.
And Bo, how are you feeling at this point?
I'll echo what Sandy said. I'm extremely excited. This has been a long time in the making. I was actually talking with somebody else who's part of the operations team just the other day, and I was saying how TAG felt surreal, but in some ways the sample return itself is taking that surrealness to a whole nother level. We've been working on this mission for over a decade, and if you count the proposal phase, it's getting on to close to 2 decades. So to spend so long on something and to have it finally become real, it's pretty extraordinary.
Well, and you mentioned TAG, the touch and go sample acquisition mechanism, which you were the project lead scientist on. You talk a little bit about the development of that, and when you finally got to the moment where you were going to make contact with Bennu and collect the sample. How was that for you and your team? Bring us into that room, what that experience was like.
It was
And we have touchdown!
amazing. When you think about everything that the whole team had done over the course of many, many years to get ready for that moment, the spacecraft had been put through its paces, the operations team had been put through its paces, the science team had done everything it could to find a sampling site that would work for the mission. So everything had been tested, everything had been evaluated, everything had been addressed. except for that final moment of the spacecraft actually touching the asteroid. So the last thing we had not done, that we had not actually demonstrated in flight, was the sampling event itself. And so it was exciting on a number of different levels, which is it was finally here. We were finally doing the thing that we had prepared to do for so long. And it was that last moment of anticipation of, is this going to work in the way that we expected? And so when we got confirmation of touchdown and we started to get the data back from the actual sample collection event itself, it was remarkable. It was really, really just an incredible experience that still to this day is a little bit hard to put into words. Just the fact that it worked so well, and something that we and everybody else had spent so long working towards was so successful.
And Sandy, as the program manager for the Lockheed Martin side of this mission, we're getting up to the point where the teams will make their final assessment of if things are in the proper place to release the sample, get it ready to actually bring itself back to Earth. Talk us through those final steps of assessing whether or not the OSIRIS-REx spacecraft is in a position where it can go ahead and make the release that everyone is anticipating. And for you, what would be, never want to wish this, but, what would be the circumstances under which it might not be able to release it and have to continue on and make that pass at a later date?
Yeah, so from the spacecraft side, we're almost configured completely for what we need to do. We did our final trajectory correction maneuver yesterday, and that all looks good. There's another opportunity later this week if our navigation team thinks it's necessary. Spacecraft-wise, we have a little more configuration to do on board, but we get that configuration done about 2 days prior. So as long as everything continues to go nominal, which we fully expect it to, it will be easy from a spacecraft side to be go. We'll know the spacecraft's configured, the files are on board, but there are other project entities that feed into that, right? Our entry, descent, and landing teams and our navigation teams, showing that we are, in fact, right in the range in the ellipse at UTTR that we're expected to land in. So all of those things come together, but we're getting that data now. Everything is trending to be a go. We'll make that go decision at 2 a.m. local time. So that's Mountain Time on Sunday morning for a release right at 4:42 a.m. So, but we have a good idea now that everything looks good, and we hope it trends that way. If for whatever reason we are a no-go, right, there is, whether it be the spacecraft or navigation or the range itself, we do have an opportunity to bring this return capsule back in September of 25. So a 2-year delay, which is not ideal, but it is an option should we need it.
And how different might that version of the return look if there needs to be a delay to that point in 25?
It'll look very similar in terms of the targeting strategy for maneuvers and the timeline for configuring the spacecraft. Really, that's all been kind of set for a number of years. It's just the actual date that moves.
After the sample is brought back, how do the roles for the two of you kind of shift? I mean, I know OSIRIS-REx will, as a spacecraft, shift names and continue on its path. But Bo, will you be involved in any of the dealings with the sample once it's back on Earth, or what are the hats look like for the two of you, post the sample being back on the ground in Utah?
I'll have the good fortune to be a part of the group down at Johnson Space Center to receive the sample when it gets delivered down there. I'm going to help the science team assess the state of TAGSAM and just make sure it's as we expect, and be there in advisory role as TAGSAM gets assembled. And then long term, I was a part of some science analyses from data that was acquired while we were at the asteroid. And some of those projects are related to sample analysis and some of the results that the scientists will get by actually analyzing the sample. So I'm extremely excited to stay in contact with the people doing the sample analysis and understand the interplay between the results that we got while we were at the asteroid and then the results from the return sample.
And Sandy, how about for yourself then?
As you mentioned, we've got the extended mission to asteroid Apophis. So we released the sample return capsule, and it has a 4-hour flight back to reentry. And in that time, we'll be executing a spacecraft maneuver to place the spacecraft on the trajectory to Apophis. The team is excited. We're going to be following along, of course. There are Lockheed Martin personnel on the recovery team. So from a Lockheed Martin standpoint, our role in recovery doesn't end until the sample canisters at Johnson Space Center are actually opened. So we'll be part of that operation in transporting to Houston and getting that open. But then we'll continue on what will be another 5.5 years of flights to get to Apophis, and then another couple of years of science around that asteroid.
And in the journey to Apophis, is there any science that's expected to be conducted in that journey phase, or will the spacecraft sort of be in, very crude terms, but in sort of like a stasis until it gets closer in proximity?
There aren't any targets that we're planning to observe along the way, but we'll be turning on our instrument suite, checking them out from time to time. We've got a couple of Earth gravity assists. We have some close perihelion passages. So there'll still be a lot going on the spacecraft in order to get it to Apophis.
And how different are you expecting Apophis to be from Bennu? Because as I recall, when the tagging operation happened, it was sort of a moment of somewhat discovery of how porous Bennu was. I know the Apophis pass is not going to be a touch and go operation like Bennu was, but from what you're looking forward to observing, how similar or dissimilar do you imagine those two asteroids to be?
I'm going to throw that over to Bo as our project scientist.
Thanks, Andy. Well, it's a great question because there's this element of mystery, right? That's part of the excitement of science, is that there are certain things that we just don't know how different they're going to be, but we can make some guesses based on what we know now. So a couple things right off the bat. Apophis is similar in size, but actually a little bit smaller than Bennu. And so it'll be one of the smallest asteroids we'll have visited by spacecraft. And one of the things that Bennu illustrated in the context of other asteroids that we had visited by spacecraft is that scale matters, right? So as you go to smaller and smaller asteroids, the surface gravity is getting smaller and smaller too. And just the dynamics of regolith and how it behaves in a microgravity environment is very counterintuitive, leading to that result at tag that was such a great measurement there. So it's possible that even though it's not a lot smaller, it is a little bit smaller. So we might see some different aspects related to granular mechanics. Apophis is also a tumbling asteroid. So Bennu has a rotation axis that's stable. It's rotating around the same rotation axis, setting up kind of a steady state acceleration environment on the surface. And in contrast, Apophis has a little bit of a tumble to it. So it's the first time we will have visited a tumbling asteroid. And that could have some very interesting consequences for what we see on the surface and how the surface and the interior interact. And then finally, Apophis is an S-class asteroid. You may be a little bit familiar with the alphabet soup of asteroid classification. But broadly speaking, there are many different types of asteroid classes, and they're designated by letters. But the two most populous asteroid classes are C-class and S-class. And S is for stony and C is for carbonaceous. And Bennu is a B-class asteroid, which is actually a subset of the C-class, without getting this too complicated. But so Apophis is an S-class asteroid, which we have seen before. So Itokawa is an S-class asteroid. Eros is an S-class asteroid. So we've seen other types, but we haven't seen one this small that's in a tumbling state. So one of the things that we've realized by spacecraft encounters with asteroids is that every one is a world unto itself. That even though these are small, quote unquote, geologically dead objects, that they're actually quite fascinating and have quite a lot of processes acting on them. So we expect to see potentially some similarities. Probably Apophis is rocky. Probably it has some porosity too, but it's going to be a very unusual world unto itself because of these interesting differences.
And going to that point, Bo, over the last decade or so, we've had a number of asteroid encounter missions. Certainly within the last couple of years that have been quite prominent with, the launch of Lucy, with the DART mission, with Psyche launching soon, with OSIRIS-REx sample return. Collectively, what are all these asteroid missions telling us about, our solar system and what are they, pieces of a larger puzzle too, as we continue to explore, deeper space and a richer variety of these celestial bodies?
That is a fantastic question. And I think it sort of gets to the heart of why NASA is so important and why these missions are so important. Because I think they're telling us at a very high level two things that, on the one hand seem to point us in different direction, but on the other hand, link everything together. So I was just saying that we're finding that asteroids, despite the fact that they're small, that they can have, quite a lot of fascinating dynamical processes. And in some sense, every asteroid we've been to is different. So these missions are telling us about the complexity of our solar system and the diversity of processes, and how we're just beginning to scratch the surface of the ways in which our solar system has come to be, right? And what we see today is the event of a lot of it's an incredible tapestry that we're just starting to figure out the individual threads for. But on the other hand, it is a tapestry, right? All of these threads are woven together. They're interconnected with one another. And I'll actually use the example of Juno. Juno is a spacecraft in orbit around Jupiter right now. It's one that we also built and are operating in the mission support area where Sandy is. And we're discovering some things about the interior structure that are totally turning our heads inside out about what we thought of Jupiter. And the reason why I bring up Juno and Jupiter is because we think that the formation of Jupiter had a major role in defining how much material got transported in and out of the solar system. So, the two most massive objects in the solar system by far are the sun and Jupiter. And you've got sun in the middle, and then you have, sun in the middle of the solar system, and then you have, Jupiter a little way out. And when you form Jupiter, Jupiter sort of becomes this barrier, somewhat of a barrier between transmitting material in and from the inner solar system out or from the outer solar system in. And so how big Jupiter gets and how quickly Jupiter gets informs how you deliver outer solar system material to the Earth, for example, or vice versa. And what we're seeing is that there are objects, such as the ones that Lucy might go visit. In the outer main belt, there are these dark objects that bear similarities to Bennu, and there are some people that think that these things may have come from the outer solar system. So the asteroid missions that we're doing, like OSIRIS-REx, like Lucy, are going to have connections with Juno at Jupiter, because they're going to tell us a lot about how the early solar system formed and how these different reservoirs of material were interacting with one another. And that brings us back to Earth, right? There are still some very fundamental questions about Earth that we don't entirely understand, like where Earth got its water. We don't know the answer to that yet. Did it mostly come from the inner solar system? Did it mostly come from the outer solar system? Sorry, long story short, these missions are incredibly profound because they are telling us about the complexity of the solar system, but they're also telling us about how The more we learn about other planets, the more we're learning about Earth and our place on Earth.
And I'll wrap up our discussion by throwing it to Sandy. As someone who's been involved with a number of sample returns, obviously another big one that we are much looking forward to is the Mars sample return in the next several years. How do you think the litany of opportunities that you've had and others like you, up to and including OSIRIS-REx, will help inform and navigate around some of the big challenges of retrieving those samples that Perseverance has been collecting on Mars and bringing them back? And what are you excited to see happen with all of that?
I mean, any sample return to me is exciting because we can learn so much more having samples here on Earth, right? You're very limited in what you can carry on board a spacecraft and how much science you can really do in orbit. So Mars sample return is definitely exciting. It's on the forefront of a lot of people's minds here as Perseverance is collecting those samples, like you mentioned. And anything we learn from OREX, right, is getting passed along to our Mars sample return partners. There are a lot of differences, of course, between what we've done and what we're doing on OREX to Mars sample return, but anything applicable gets passed along. So I'm excited. That's a very exciting program. We're building some of those components here at Lockheed, so it's neat to see those come to life. So that will definitely be an exciting mission here in the next decade or so.
I certainly don't want to look past the one we're coming up to the next big chapter closing on. So thank you both for joining us, and best of luck on Sunday. Rooting for you guys.
Thank you.
Thank you very much. Appreciate it.
Our thanks again to Sandy and Bo for spending part of their day with us, and thank you for sticking around. Again, the sample from Bennu is getting ready to touch down in the Utah desert the morning of September 24th. It'll happen at 10:54 a.m. Eastern Time. That's 14:54 UTC. Again, thanks so much for spending part of your day getting a little bit more educated about the OSIRIS-REx mission. We'll have more coverage leading up to that point, so be sure to stay right here with Spaceflight Now. And for Spaceflight Now, I'm Will Robinson Smith.